Hi, everybody. Welcome to our session on what's new in Compose Multiplatform Alive Tour. If you're still trickling in, please find a seat. You are more than welcome here. We have a lot of exciting stuff to get through, so I don't want to spend too much time on intro stuff. My name is Sebastian. I'm a developer advocate for Kotlin and Compose Multiplatform at JetBrains.
And my name is Márton, and I'm also a developer advocate at JetBrains.
So yeah, that part you can easily remember. We're both developer advocates. The name's still somewhat individual. So the reason why we came here today is we want to pose a simple question, which is, what if you could just do iOS? And the fun fact is that for a lot of folks who are in this room, it turns out you probably can, which is quite exciting. Why is that, Márton?
That's because more and more of the Android ecosystem is going multi-platform over time. We see a lot of libraries that were originally designed to be used on Android, which are now available across various platforms supported by KMP. And of course, one of the recent very exciting announcements in this space was that Google is now officially supporting Kotlin Multiplatform for sharing business logic across Android and other platforms, which was just at I/O.
Very cool. So we figured the best way of actually seeing what's possible with Kotlin Multiplatform, Compose Multiplatform, is by just building an application. So we're going to spend essentially the rest of this presentation just in our editors actually working on something, and we'll build like a small expense tracker, something where you can add a couple of expenses, you can assign them to an account, you'll be able to see at the end who has actually paid for things, the total that's owed, and we'll be able to run that not just on Android, not just on desktop, but on iOS as well. And hopefully you'll see a lot of very familiar things throughout this talk. Of course, we want to do this fully featured, not just like a scaffold or like a shell. So we want to have fully shared Compose UI. We want to make sure that the logic is properly separated from the actual UI. So some sort of architecture components here. We want to have proper navigation back and forth. Things like resources we also want to cover for image loading. We probably want to have some sort of preparation for localization. Maybe we can even do something there. And of course, expenses don't really make sense if you just hold them in RAM. So we probably also want to have some sort of database solution, plus dependency injection just for the overall structure. So,
and for the UI part, of course, we're going to build all of this using Compose Multiplatform, which takes the idea of Jetpack Compose, which was built by Google for Android, and this is built by JetBrains, and it expands Jetpack Compose to multiple platforms. More specifically, there are the supported platforms for Compose Multiplatform at the moment. So on Android, it's reusing Jetpack Compose as is. On desktop, it's also fully stable. It has been for a while. And then on iOS, it's currently in beta. And on web, it is in alpha. And we're, of course, looking to move these towards stability in the future from here.
Cool, what a delight. Well, with that, we can actually start hopping over into Fleet with Kotlin Multiplatform tooling in a second, which is what we'll use today to build things. Just in case you're wondering why there's like two laptops weirdly stacked here, we have a collaborative setup, which means you will be seeing my machine where Fleet runs, where all the emulators will be running, where the source code and the actual like code intelligence will also run. And then Márton is already connected via the conference Wi-Fi, so hoping that that's going to hold out, is actually going to be connecting here. So you'll also see Márton's cursor, and he'll be able to do any kind of actions while we're developing here as well. OK, so with that, time for us to actually go into our demo. Just hop on over here. There we go. Great stuff. OK, so what I would love to do is to start building a little bit of UI, just a couple of components as a warm-up. But to do that, I kind of need to know what kind of data I can actually render. So Márton, I'm just going to follow you here. Why don't you walk us through what we got?
Excellent. So we already have some data classes prepared for you here so that we can use that. So we're going to be tracking expenses. That's going to be our primary model. It has an ID. It has the ID of whoever has paid for that expense. It has an amount and a description. Then we have the person entities, which have, again, just IDs and names for now. And then we'll also want to work a bunch with both an expense and the full person's details associated with the expense. So we also have this combined data class called expense with person, which just has both of these entities in there.
Great, wonderful. That's probably enough for me to actually start building a couple of things already. So the main two components that we have are, first of all, this kind of person item, we've already provided a little bit of a scaffold here in our preview, which is just an avatar of a person and then their name below it. As you can hopefully tell, that's not a particularly complex thing. The way that we've already built this here is that we're entirely in the common main source set, which means all of this code can be shared between all the different platforms that we'll be targeting. There is still something missing here, though, which is that the avatar doesn't actually show a picture. It just shows some kind of circle. So we can actually hop into this avatar function over here, and we can just start editing. We probably need some sort of mapping from a person to their specific avatar. So we already kind of prepared that. We can take a look at what that looks like in a moment. But essentially, we can just look up the person for or the avatar for a specific person. And then if that does exist, then we can just create a new image. These are all APIs that are probably already pretty well known to you. So I can just use an image resource using that specific drawable resource. We can also specify as a content description the person's name because it's just an avatar. And probably if we let this render, we can already see that Blake is now showing up with his profile picture. We can also make sure that if the images are actually differently sized, I can set myself a modifier to make sure that this is actually the maximum size and also set up the content scale. Nothing out of the ordinary here, except that I typically like to use crop. I find that very unintuitively named, honestly, but if you do click into it, it is the modifier or the content scale that makes sure that the image is blown all the way up so that it actually takes the entire space. Okay, so that already looks pretty good. We can actually click into our people to avatars here and see that this is indeed just some demo information that we have so far. So it's just our demo people, which are these objects associated with a couple of drawables. And those drawables, as you can see, we access using res, not using R, because these are multi-platform resources. So we can actually click into these and we can see over here in our common main compose resources, we have a couple of very good looking stock photo models, all the typical people that you might expect. And yeah, so this is kind of the basic setup. So first component done. I think what we can do now is actually start writing something slightly more complex, which is this wonderful expense item. Again, avatar, text, a little bit of layouting. So why don't we actually take a look and see how we would build this? Okay, overall, this is clearly a row because we're going from left to right. We know that there should be an avatar here. That's just the person. And we can specify also a size. So in our case here, that might be like 40 dp. And we'll already see that that's showing up over here quite nice. We can make this a little bigger so that it resizes. Gorgeous. Then we probably have something like maybe a column, right? So because we want the text to be above each other, we know that the expense has some sort of description that goes at the top, and then at the bottom, we probably want to provide something like paid by, and then that paid by's name. Now that is one way of doing it, but of course we want to prepare already for localization. So rather than do this, we can actually use a string resource that is now also available for multi-platform. So I can just use string resource here. And in our case, I already have something prepared. It's just called resstring paid by. And that's pretty much all you have for this. Of course, this still comes with a placeholder. But if I actually jump into this, you can see over here at the in my compose resources in the common folder, I have my paid by string. That's just set up in the same XML format that you already know. Okay, so moving back here, Márton is getting a little antsy apparently. So you already added a couple more things here. We can just quickly kind of go through this. As you can see, there's a syntax for replacing or using those placeholders, in this case with the name, and then overall, okay, you just made it a little bit nicer. We added some padding, we added some weight.
Font size.
You also added some weight here, which is nice, which means this actually scales correctly as I make our image, or as I make the preview wider and less wide. It's not perfect though yet, because this money up here, this actual value seems to be like stuck to the top. So what I guess I can still do here, so that I also have contributed something, which is just grabbing an alignment and making sure that this actually centers vertically. Let's take a look. Okay, that actually looks a lot better. Everything's kind of well aligned now. It sounds like with this, we could probably already start building like proper screens now, right?
Yeah, I think we can get moving.
Cool.
And the first thing that would be nice to do here is, as we mentioned in the introduction, we want to nicely separate our logic from our UI code. So it would be nice to have some kind of state holder for that. So let's hop to the slides.
Very cool. Just take a quick look here. And there's actually a couple of different ways of how we could do this. KMP Observable View Model is something that was built from the community. There's also stuff like Voyager, which provides you like a screen model, and also actually comes with an entire navigation library. There's things, if you like model view intent, with things like Orbit MVI, you can also use Molecule, which is like bringing the composable functions and even separating from the UI. But today, we're just going to use Jetpack View Model, like the original view model implementation, because that is now also available in multi-platform code. So I think it should be pretty easy for all of you to follow this code.
Yeah, and I already got started with that. So our first screen is going to be called the home screen. So I'm starting that by creating a home view model, which is going to inherit from view model. Once again, it's the Android X lifecycle view model import. So it's literally the same view model as you have already hopefully encountered it on Android. In here, we'll want to provide the UI with that list of expenses that's going to be on our main screen. So that's going to be some expenses, which we can expose as a state flow. Within that state flow, we can put a list of expenses with people. And for the time being, we're just going to hard code some demo data here. So I'll simply create a mutable state flow, and then we have some demo expenses with people that we can pass in there and expose that to the UI.
So one of the things that, of course, you can't see up here, but Márton does, of course, get all the pop-ups for completion and so on. Those are not just mirrored to my screen, but they're there. That's how he can type all these things so quickly.
Yes, thank you. Also, while we're here, we can take a quick look at this demo data again, which we have prepared in advance. And you can see that one of the things that we're using here as an example is random ID generation, because we just want IDs for each of our entities. And if we hop in there, you can see that the way that we're doing this in a Kotlin multi-platform compatible way is that we've pulled in a community library, which already does the work of bridging UUID generation to each of the platform-specific implementations.
Yeah, luckily, in the very near future, though, you will actually not require this anymore. So you can see that with the target version of Kotlin 0.2020 beta 2, we will actually get multi-platform support for UUIDs as well. So you can see this was updated 6 days ago. It's still a pretty fresh one. But yeah, this will allow you to shed one dependency if you're doing multi-platform and get a really nice and idiomatic Kotlin version of this going as well.
Okay, let's get started with the UI part. We have already prepared a bit of a scaffold here for the home screen for the main parts of the layout, but we'll do the integration with a view model now. So first things first, we want a view model to be accessible within this screen. And a nice way to do that is by providing it as a parameter to our composable function. So we can create a parameter here, which is going to be a home view model. And I can use the view model function. I'm going to import that. And tell the framework how one of these view models can be created, which for the time being is just calling its constructor. Then we can grab this view model and extract the data from it so that we can render it on the UI. So for the expenses, we can use viewModel.expense, which is the state flow that we've just created, and then collect that as state. If you're using Jetpack libraries, you might already be aware that there's also a better variant of this function, which can also take lifecycle into account, so that whenever you are consuming some kind of flow which uses significant resources under the hood, when your lifecycle gets into a certain state, you want to stop that collection. So luckily, we now also have the collect as state with lifecycle function available with Kotlin multiplatform and Compose multiplatform. So we're just going to use that version from here on. So we need to display all of these expenses in a column here. We have a lazy column prepared already, so I'm going to populate that with some items. I'll pass in the expenses that we're getting from the view model. And then in there, we already have this expense item that we wrote at the beginning of the presentation, and that requires an expense and a person to be passed in. And as you can see from the inlay hints, which are in fact enabled on that machine as well, we are getting that expense with person as a parameter to this lambda already, so I can just destructure that just like this in the incoming parameter, and that fits nicely. The rest of the things we need to display here are the total that we have spent across all of the expenses that we have. So let's quickly calculate that here at the top. This is going to be based on our list of expenses. So we're going to key it to that. And we're going to remember this so that we don't recalculate it across recompositions all the time. So I'm going to take the expenses and I'm going to do a sum on each of the expenses and take the amount out of there. So that gives me just an int, which represents our value. Here again, I could use string templates to put this into a string, but we have, in fact, already prepared string resources for this as well. So I can go to our resources, look for strings, and then we have a resource called total, and I can just pass in the int value to actually fill in the placeholder, which, if you're following me, we can hop over here and we can see that there is a placeholder in this string as well. Okay, finally here, we want to hook up this button, which will eventually navigate us to a second screen where we can add new data to our application. So here, again, we want to have a nice label for it. So we're going to have a string resource, which is going to be the add expense string, which we have prepared. And then we need some kind of callback that we can invoke whenever a click happens. So I'm going to create a new function parameter up here. I'm going to call it add new record. It's going to be a function with no parameters like this. And now that we have that, we can invoke it whenever the button is clicked.
Very nice. I think from there, pretty much all that's left is actually hooking this up in our actual application.
Yeah.
Hop on over here. We can replace our little hello compose here with our home screen. For now, we will just not do anything when on add new record happens, and the view model will be wired automatically because you used a factory function. So from that point on, it seems like we're actually able to run this application, right? So we can start it on desktop, for example, but of course we can run it on any of the platforms. And that already looks pretty good, looks pretty close to the images that we've shown in the beginning. Of course, it doesn't really do a lot. All the data is still demo data. All the buttons don't really do anything. So it's time to build a couple of features. Before we do that, however, I do just want to quickly demonstrate that now, because we extracted all the strings, we of course are well prepared for doing some localization. So I can actually hop on over here into our compose resources and I can provide a parameterized version of this values folder. So we're in Berlin, and also I am German, so we can create a German translation because that's the only one that I could reasonably check. And we can just throw this, I can just copy paste this in here, and then I could use something like AI Assistant to just translate this to German, and we'll figure out if that looks vaguely correct. Ausgabe hinzufügen, Beschreibung, Betrag, Summe, bezahlt. Okay, that all looks pretty good to me, so we can just keep that as a, what do you think?
Oh yeah, it sounds fine. I'll trust you on this one.
If it's Márton approved, then I think that's great. Okay, so I can actually run this now on, for example, the iOS emulator. And if you take a look here, you can see it says Kontakte, Dateien, Kurzbefehle. This is a very German iPhone. So yeah, I love the word that Kurzbefehl is just such a wonderfully long word for shortcuts. So yeah, you can see now that it says bezahlt von Blake. We have Ausgabe hinzufügen, Summe. This all looks pretty good. So it just gets picked up automatically. And other things, like if we had, for example, images that were specific for dark mode, those would also get picked up automatically. Great, wonderful. So now, with that out of the way, I think it's time we build some actual logic, right?
Yeah, let's build something where we're not just putting the demo data straight into our view model, but we're actually persisting that in some kind of reasonable data layer. So for that, if we can hop over to the slides real quick, we also have plenty of options with Kotlin Multiplatform for storing data that have been created over time. So we have database libraries like Realm and SQLite for structured storage. We have case store, which allows you to store objects in files, essentially. We have key value stores like data store or multi-platform settings, which are all great libraries. But today, we're going to use one of the latest and most exciting one for Android developers, which is Room, that's now also available for Kotlin multi-platform. So,
what a delight.
To do that, no, we're not using SQLite, we're using Room. Come on. For this, we need to start adding some annotations to our entities so that they can be stored in tables using Room. I'm going to do this as well with AI Assistant, which again, you can't see on my side that I'm invoking it, but trust me, I'm prompting it with add Room annotations and include foreign key because we want a connection between these two tables. So let's see what happens when we do that. Okay, so we have the same properties as before, which is good. As you can see from the little diff markers, we have added this primary key annotation to the IDs of the entities, which looks good. We have annotated them each with entity. Something else we can do here if we want is make the table names a bit nicer. So the expense table I can parameterize to be called expenses. And then for the person table, we can call that the, we can call that the people table. And then we have a foreign key here, which connects this ID, which should refer to a person, and we want Room to validate that that person actually exists by the ID. So we're defining that as connecting the expense class to the person class. The parent column, which is going to be the one on the other side of the reference, is the ID column. This is the column in this class, and we can also automatically delete if a person is removed. So all of that looks good. The only other thing we have is this smaller data class at the bottom of the file, where what we want to do is we want to embed the expense. So we want to be able to query for expenses, but actually get back these wrapper data classes from Room. And we also want to define a quick relation here. So we want the person that's appropriate for the given expense, again, following that foreign key, to be fetched alongside the expense. And I think that's all of the setup that we require on the entities side. So with that, we can keep moving and create an actual database class. So I'm going to call that expense database. I'll create a new file for it, which again, you can't see that I'm doing that, but it's the same UI as what Sebastian would have if he would navigate that panel. And in here, I'm going to create the expense database, which is going to be a Room database. And again, it's an annotation processor, well, KSP processor now. So we have to annotate this. We have to list the entities we want to use. So that's going to be the expense class and the person class. And we have to specify a version. Because we've been doing this demo, I'm not going to specify version 1. We're going to go to version 3 immediately, just so that we don't have any database conflicts there. Then the other thing we need to actually access data from here is we need to use a DAO, so a data access object. Something like an expense DAO, like this. And then Room will generate an implementation of that for us. So if I create actually an abstract function, because we want the implementation to be generated, I can return an expense DAO from here, and Room will take care of actually giving us one of those. Now, I will start writing some operations here just to unblock Seb in actually implementing this in other files. So I'm going to create the first and most important query, which is going to be getting all of our expenses alongside people. From here, I'm going to return a flow, because when you're using Room with KMP, everything that you use either has to be a one-time suspending call, or it has to return a flow. So you always have to use coroutines in these data access objects. And this is going to return, unsurprisingly, at this point, a list of expenses with people. And we're going to have to write a quick query for this, which is going to be simply selecting everything from the expenses table. And because we know that we're returning one of these combined types, I'm also going to add a transaction annotation on here, which is a best practice with Room.
Okay, well, we can let Márton tinker away a little bit with this, but we actually now have everything we need to wire this up in the home view model, because now we actually know how to, first of all, get an expense DAO. Or we know that we need one. Probably this will have to be provided to us through the constructor. We'll worry about that later. But once we have one, what we do know is that we can grab this expense DAO and we can call get all with people, which is what Márton just implemented. And then from there, all we need to do is, well, it's a state flow. So we want to turn that into a state flow the typical way, using state in because this is just a view model, we can just use the view model scope, which is the required coroutine scope for this state and function. We can also set up how it should be started, which in our case oftentimes is something like, well, while there are subscribers with like a timeout of maybe 5 seconds or so, and while nothing is loaded yet, we just have an empty list. Okay, Márton, have you been busy?
Yes. I've added some more code to our expense DAO over here, some more queries we can use to access the contents of the database. So we're also going to have a function that returns the full list of people available, which we're going to need for our second screen that we'll build. We have simple functions which can just insert new entities into the database, and we have a function that allows us to delete the contents of the database, which we're going to do here a bunch of times for testing purposes. And then up here, we also have function which I prepared to help with instantiating a room database. So first, we'll need to get a builder, which is going to be a platform-specific way of creating a room database builder that will be able to create an expense database for us in some certain file. And then we have some common configuration here that I've written. So we're going to set things up like the SQLite driver, as well as for the coroutine usage, we're going to make sure that all of that happens on the IO dispatcher.
Now, of course, Márton didn't invent this code snippet. Instead, you can actually head over to the Android developers documentation, and there's an entire section on Kotlin Multiplatform now. Okay, you can just look for room Kotlin Multiplatform, and then there's actually an entire section on creating the database builders. In this case, what you were just looking at was essentially just this function, right, which was the get room database. But it also tells you what kind of configuration you should do for each specific platform. So on Android, for example, you'd pass in a context and then would use that context to get a database path, which is the idiomatic way. On iOS, you would do something like use NS home directory and then put the database in there. And on desktop, super simple, you just do a file and you could maybe do that into the temp dir or wherever else you'd store things. Great.
Yeah, and through the magic of collaboration here, I have already prepared those exact snippets into our project for us. So on Android, again, we're going to use the context. We're going to grab the database directory from here. And similarly on other platforms, such as on the JVM, we're going to grab the temp directory for our purposes here with the demo. And we're going to put the file here, and then just similar thing for iOS as well. From here, all we need to do is actually call these functions on each platform whenever the application starts. And then we kind of want this database to be connected to our view model. So some solution to wire these together would be pretty nice to use. So what do we have available for that?
Yeah, I mean, so this clearly seems like we want to do some sort of dependency injection. You could use things like Codeine, Kotlin Inject. There's a couple of different ones. Today, we're using Coin, especially because they also already shipped experimental integrations with Compose multi-platform view models, which makes our life even easier. And also, that's the one that we pre-configured for this project. So,
yeah, and I've already started writing some of the code that we'll use for that. So we'll have an initcoin function in our common code, which we'll call into from each of our individual applications and pass in that database builder, which contains the platform-specific file path for where the database should be stored. Then we're going to create some modules, which will define what Coin should be able to provide to us. So for example, we'll want to inject an expense DAO into various places. So we're going to create a function that can provide that. Here I can essentially take the database builder and then call that common configuration method, which again we've defined earlier here. And once we have a database, I can take an expense DAO, and because I've defined this as a single, it's going to be a singleton object here. What we also need is connecting this with our view models. So I'll create a view model module. Again, it's going to be a Coin module using the DSL. There's also a specific DSL here for working with view models. And with home view model, I can instantiate it here. And the required parameter, which I'm seeing with the parameter hint on my end, if I invoke that shortcut, is going to be the expense DAO, of course. Thank you. And I can just call get with the Coin DSL, which is going to grab it from the already declared Coin dependencies. And finally, we can call start Coin and add the required modules, make sure that we have the imports for these, and pass in, of course, our data module as well as our view model module. And from here, I think we just need to call this function in each of our apps to initialize coin.
Yeah, so we can just do that. Essentially, what we'll do is we'll hop into each entry point for each platform and make sure that that function gets called. On Android, that would be our onCreate function inside the application here. So we'll just call initCoin, make sure that we have that one here. And all that takes is that database builder, right? Which in our case would just be calling the create database builder function, which on Android takes a context. But luckily, we're in an application object, so we can just do this. So again, this specifically now calls the Android-specific version to set everything up, since we're in the Android part here. On desktop, things look pretty similar, so I can actually hop on over here. Our entry point is just a main function, so I can actually just call this right at the top of the main function, and that will work just fine. The only part that's slightly different is the iOS one, because the app entry point actually gets wrapped in this compose UI view control, and if I command click this, at least if I'm in the Kotlin multi-platform tooling in Fleet, then this will actually send me to the Swift code where this is actually being instantiated. And if I kind of go up here, so the compose view is actually used by content view, and this one is our iOS app Swift, that's our entry point. So in this place, I would most likely just want to call the initCoin function. I don't want to instantiate the database in Swift and then pass it back into Kotlin. So instead, I would rather use some sort of helper function so I can call it without any arguments. Probably would live in coin iOS KT and then just call do initCoin, which thankfully Márton is already busy building this. It's a pretty simple function. It just provides the iOS specific database builder here and lives under the iOS source set. That's pretty nice. I think we're pretty close to being able to run this again, right?
Yes, we're missing one thing, which is that now that we have told Coin how to instantiate our view model, we should make sure that we use that when we're creating the view model. So if we hop over to the home screen file, we have to fix that because we were using this original view model API and we were creating the view model by hand here. So instead of that, we should be able to call Coin view model, and that will just grab a view model through Coin, including the injected dependency automatically.
Great. Well, with that, we can actually run the application. So we can run it on iOS, run it on desktop, run it on Android. You can actually take a look here. And this looks quite similar as beforehand. Where's this data coming from, Márton?
The data is coming from us dumping the demo data into the database so that we didn't just open an empty screen. But please trust us, that's going through Room, and that's what we're observing. We'll add new entries to it in a moment.
OK, yeah. So you can see that, once again, that works on all three platforms, and it looks exactly as you would expect.
And now that we have launched the app at least once on each platform, I'm going to remove that demo code so that we don't clear and reset the database each time.
Great. OK, so what's left?
Yeah, what's left is adding new entries, right? So we should quickly build a second screen, which allows us to add new expenses to our database. So for this, we're going to, again, create a view model first, start from there, and then build the UI on top of it. So our add view model is going to be a view model, like the one before it. And we want to inject, again, an expense DAO here, because that's what we'll use to actually insert new entries into the database. The most important part of this, yeah, I think at this point, if you could help me out, you can already hook this up with Coin on the other side, right?
Yeah.
Because we already have the constructor, and that's enough for us to get started.
That sounds great. So I'll just hop on over to Coin here, and I'll just follow the same pattern that we had beforehand. So this is just the add view model, which just takes an expense DAO again. So it's the exact same pattern. OK, I can see you typing quite frantically over there. So what happened here?
OK, so we have a very quick implementation of the add view model here. So in this one, again, we want to show all of the people so that you can select who you want to add an expense for. We're grabbing that from the DAO now, observing it as a flow, converting it into a state flow using statein. Just once more, it's the same view model APIs. We have things like view model scope that we can use, so it looks just like if we were writing this for Android. Then we'll have another state flow here, which we can use to signal to the UI that the new record has been created. In that case, we can close that second screen later on. And we will have a create record function here, which the UI can call into once the appropriate data is input. And as you can see, that's instantiating a new expense, generating an ID, passing in the rest of the parameters. And finally, okay, this is the last time. It's the same APIs. We again launch a coroutine using viewModel scope. We insert something into the database. And once that's done, we flip that state flow to true so that the UI knows that this was successful. From here, we can build this screen that actually displays the entry screen. So here we're going to start out with the signature again so that we can parallelize some of our work. So we're going to create a composable function. It's going to be called addScreen. Importantly, it will take one of these viewModels as a parameter. So it will have an addViewModel parameter, which again, we're going to set up using coin. So I'll just call into coin viewModel to get that and opt in to the experimental API. And the other thing that this screen really needs to do is signal to whoever is calling this screen whenever we cancel the operation of adding a new record or whenever we successfully edit something new. So for that, we're going to add an onDone callback function here that we can take as a parameter. And with this, we should actually be able to start hooking this up to the rest of our application.
Yeah, but of course we kind of need to go back and forth between multiple screens here, so it's time to figure out how we navigate. And once again, Voyager already appeared earlier. It's a complete multi-platform solution with like screen models as well as navigation, things like pre-compose and a whole bunch of other libraries that actually already do this. But we want to show you today that Compose Navigation, which is a library that, again, you might already know, is now also available for Kotlin multi-platform and Compose multi-platform, which is quite exciting. This is actually something that we at JetBrains converted to multi-platform. Was a bit of effort, but it seems it was worth it. And you can just use the same APIs that you already know. I said it wasn't my last time, I was going to say that. So yeah, it also means that if you have an existing app, you'll just have an easier time transferring this over. And of course, it also keeps evolving with things like type-safe multi-platform navigation that's going to drop quite soon. Okay, so I can actually, now that we already have the scaffold, I can actually start building something here, right? So the entry point typically is just the nav host in Compose Navigation. So this takes a nav controller, so we can just kind of fill this in the same way we would like fill in a form. So we'll just do a remember nav controller here. We'll do the nav controller correctly. Then this also takes a start destination, which in our case would just be home. So we can do, we can make sure that that's set correctly. And then what we also need is the actual navigation graph. So in our case, that would be our composable route for home. That's where the home screen lives. So we can move that in here. And then we also have this compose. Look at this. It's getting more exciting now. We also have the add route, which is going to be this add screen that Márton is currently building. What I'm going to do in this very moment is I'm going to hand Márton my power plug so that he can figure this one out, because that would be a shame.
And this is peak collaboration.
So we also have what I prepared is also a couple of transitions. These aren't particularly special. They just make it a little nicer to see that we are actually navigating back and forth. The add screen takes an onDone parameter, and the view model gets hooked up automatically. So now we just need to be able to actually navigate back and forth. So we do that just once again by grabbing ourselves the nav controller, and we'll just navigate to the add route here. And likewise, when we are done, we'll grab the nav controller and we'll navigate up, which is conceptually the same as you would expect. Okay, cool. How's the add screen going so far?
Yeah, we're done with the add screen in the meantime. So this is going to be a lot of compose code. We'll fly through it just at the high level. So we have this record created state flow up at the top, which whenever it flips to true, we call the onDone callback. Then we have a couple parameters here, which are the input state, so the amount, the description that the user types in, and the selected person's ID. And then we observe the list of people from the view model, once again with collect as state with lifecycle, so that it's lifecycle safe. We have a lazy row displaying those people in a person item, which was something we built at the beginning. And then at the bottom of this screen, we're going to have two text fields. and a button. The most exciting part of this is that in one of the text fields, we want to have only numerical input for the amount that was spent. So we're filtering any input characters so that we only keep the digits. So regardless of what kind of keyboard the user tries to type on, we don't accept characters that are not numerical. And we also, for software keyboard support, we also set the keyboard options necessary so that it's not the full QWERTY keyboard that's shown, but a numerical keyboard specifically. And then at the very bottom, we have the button, which when clicked will call into the view model that we built earlier and trigger creating a new entity.
Great. So with that, we can actually see that once again, our app runs on Android, on desktop, and iOS. And I can grab, for example, the iOS one. I can have Drew pay some money for my droidcon tickets over here. Probably what would be also nice to see is if I enabled the software keyboard, you can see that this is actually hopefully not that expensive. And then if I add these and I scroll to the bottom, you can see that these are indeed persisted, and that, of course, works across the different platforms. It works pretty much everywhere. Kodi meeting. Great. So we have all of this, and I think with that, we've actually reached a good point where we're done. We've built something that's like an entire app. So now, hopefully, you understand that with the skills that you already have, you can't just build for Android, you can't just build for desktop, you can also build for Apple devices as well, which I hope is a little exciting to you.
We are running out of time, so we'll wrap this up quickly. Of course, what we've shown here is just a very, very small sliver of the available libraries for Kotlin Multiplatform. There are literally thousands of more Kotlin Multiplatform libraries that you can already use to build multi-platform applications.
That's right. If you want to start your own journey, first of all, if you're in the room, come talk to us. We have a booth, and we'll be doing demos, and we'll also be just answering questions there. But you can go to jb.gg/compose, which will bring you to our big entry point. And also, if you're not in the Kotlin Lang Slack yet, make sure you join there, because there's a bunch of different compose-related channels there with a lot of super helpful people. So thank you so much. Hope that you will try this at some point, and enjoy the rest of droidcon.
Thank you.